Okay, hi everyone. Today's lesson will be on velocity. So, we will be talking about the velocity graph, which is position versus time. But before we do that, we'll be talking about displacement and distance, and then distance too. So let's say we have 2 points, point A and then point B, and they're 5 meters apart. So in terms of displacement, which is how far an object is relative to its zero position, so its zero position would be A because it's starting there. So if this one specific scenario is if it went from A to B, the displacement would be 5 meters because it's 5 meters from its zero position. However, if it went from A to B, which is a displacement of 5 meters, and then B to A, its displacement would be 0 because it's 0. It's not it's sitting where it started, so it's not apart from its zero position. But in terms of distance, which is how far an object moves, so if it went from A to B, it would also be 5 meters because it moved 5 meters, which is the same as the displacement. However, if it went from B to A, that's another 5 meters traveled. So if you do 5 meters plus 5 meters, that would be 10 meters traveled. Unlike displacement's 0 meters if it went from A to B and then B to A. On to the position versus time. This person put displacement not exactly correct, but you see that sometimes. So on the y-axis it would be position or displacement. On the x-axis it's time. And the slope of this graph, so this part right here, that part right there is the slope. So that slope is velocity. And we know that because one of the equations is change in x, which is change in position. X is always position, and change in position is displacement. So change in position over change in time is velocity. So this is basically what it is. It's change in y over change in x. So it's the change in position over the change in time, which is the velocity. So the slope is the velocity. And we can derive another equation from this. And this equation is x equals vt plus xo. And x naught. X naught is basically just a starting position. And you can derive this equation from y equals mx plus b. And so the slope is velocity, as we already learned. X is the time, y is the position, and then the y-intercept is the starting position. And this makes sense because if you went through here and then came up here, then the 2 points you would take is this right here, and then this one to find the slope. And this is the starting position because you have to take these two things. You have to take these 2 points and to find the slope, which makes sense. And okay, we just learned about positive constant velocity, so now we're going to look at different types of velocity graphs. So this is a negative slope. So I'll ask you a question. What does this exactly mean? Okay, it means that it has negative constant velocity according to the slope. To find the slope, it's change in y over change in x. Or in other terms, it would be change in x, which is x is always position, over change in time. And this is to find the velocity, which is the slope. So I'll put my work in different colors. So the initial position is 4 right here, and the ending position is 0. So that would be 0 minus 4 over 10 is the ending for time, and then it would be the starting is 0. So it would be 10 minus 0. And this is negative 4 over 10, which makes the slope negative 0.4 meters per second. And it is meters per second because the units for time are in seconds, and the position is in meters. And if we wanted to find the vital position, we would use the equation x equals vt plus xo. And as I said, this equation was derived from y equals mx plus b. So the initial, the y-intercept is 4 right here, so we can plug in 4. The velocity is negative 0.4, and then times 10. So negative 0.4 times 10 is negative 4, plus 4 leads us to a position of 0, final position of 0, which makes sense because, as you can see, it's at its starting point again, or where it was relative to this point right here, so now it's back at that point.